Hey car lovers, today we're going deep into the world of gearboxes, specifically the OG of gearboxes, the sliding mesh gearbox. This gearbox is a fascinating piece of engineering that played a crucial role in the development of early automobiles. Whether you're a seasoned mechanic or just someone who loves classic cars, understanding the sliding mesh gearbox will give you a new appreciation for automotive history. This cool invention was super important in early cars. It was one of the first types of gearboxes used in automobiles, and it laid the groundwork for the more advanced gear systems we see today. Imagine driving one of those early cars and feeling the raw mechanical connection between the engine and the wheels. It might seem old-fashioned compared to today's smooth gearboxes, but understanding how it works helps us understand how power gets to the wheels. Modern gearboxes are marvels of engineering, but they all owe a debt to the sliding mesh gearbox. By learning about this early technology, we can better appreciate the advancements that have been made over the years. Trust me, it's way more interesting than it sounds. The sliding mesh gearbox is a testament to human ingenuity and the desire to make machines more efficient and reliable. It's a story of trial and error, of engineers pushing the boundaries of what was possible at the time. The sliding mesh gearbox is all about moving gears by hand to control the speed and power from the engine to the wheels. This manual operation required skill and precision, making driving an art form in itself. Drivers had to be in tune with their vehicles, understanding the nuances of gear shifting to get the best performance. It's like a bunch of gears and shafts working together, hopefully, to get you moving. Each gear had to mesh perfectly with the others, and any misalignment could cause serious problems. This made the sliding mesh gearbox both a marvel and a challenge, requiring regular maintenance and a good understanding of its mechanics. You won't find them in many new cars, but they're still used in some big machines and old cars, which shows how tough they are. Their durability and simplicity make them ideal for certain applications, even in today's high-tech world. It's a reminder that sometimes the old ways are still the best ways. So, get ready as we explore this mechanical wonder. Diving into its history and mechanics, we'll look at how it was developed, the challenges engineers faced, and the impact it had on the automotive industry, how it works, breaking down the components and their functions. We'll see how each part interacts with the others to transfer power from the engine to the wheels, and why this system was so revolutionary for its time. Its good and bad points, weighing the benefits of its simplicity and durability against the challenges of manual operation and maintenance. We'll also compare it to the modern gearboxes to see how far we've come and how it changed cars forever. The sliding mesh gearbox was a key innovation that helped pave the way for the modern automobile. Its influence can still be seen in the design and function of today's gear systems. Get ready for a quick lesson in car history. By the end of this video, you'll have a deeper understanding of the sliding mesh gearbox and its place in the fascinating world of automotive engineering. Okay, let's look inside a typical sliding mesh gearbox. This type of gearbox is one of the simplest and oldest designs used in vehicles. It's fascinating to see how such a basic mechanism can efficiently transfer power from the engine to the wheels. Don't worry, it's not as hard as it looks. Once you understand the main components and how they interact, it all starts to make sense. Think of it like a puzzle with a few main pieces. Each piece has a specific role, and when they all come together, they create a seamless operation. First, we have the input shaft. This is the component that receives power directly from the engine. This guy is connected to the engine and gets all the power the engine makes. It's like the main artery of the gearbox, channeling energy into the system. Next, we have the output shaft. This shaft is responsible for delivering the power to the wheels. This one sends the power to the wheels to make the car move. Without it, all the energy from the engine would go nowhere. Here's the cool part. Between these two shafts is the countershaft. The countershaft plays a crucial role in the gearbox's operation. It has a bunch of gears that are always connected to gears on the input shaft. This constant connection ensures that power is always available to be transferred. The gears on the output shaft are the ones that move. These gears are responsible for changing the speed and torque of the vehicle. They slide to connect with different gears on the countershaft, and that's how you change gears. This sliding action is what allows the driver to select different gear ratios. Finally, we have the gear selector fork, which controls everything. The gear selector fork is like the conductor of an orchestra, ensuring everything moves in harmony. You move it with the gear lever and it moves the gears on the output shaft to change gears. This action is what allows the driver to control the vehicle's speed and power. It's all about timing, like a band playing music. Each component must work in perfect harmony to ensure smooth and efficient operation. When everything is in sync, the gearbox performs beautifully, providing a seamless driving experience. Imagine you're in a car with a sliding mesh gearbox. The first thing you see is the gear lever. It's your connection to the gearbox, controlling how the car moves. When the lever is in neutral, no gears are connected. The engine can spin, but no power goes to the wheels. It's like the car is taking a break. To move, you need to put it in gear. This is where the fun starts. You press the clutch pedal, which disconnects the engine from the gearbox. Then you move the gear lever to pick a gear like first gear. This moves the gear selector fork, sliding a gear on the output shaft to connect with a gear on the countershaft. It's like finding the right puzzle pieces. Let go of the clutch and boom. The engine's power flows through the gears, turning the wheels, and you're off. Now that you're moving, you'll need to change gears to go faster. This is where the sliding part gets important, and it can be tricky. Remember, the gears on the output shaft are always spinning at different speeds. To change gears, you press the clutch to disconnect the engine, then you move the gear lever. Here's the hard part. The gears on the output shaft need to be spinning at the same speed as the gears on the countershaft before they connect. If not, you'll hear a grinding noise. That's the gearbox saying you're doing it wrong. Changing gears smoothly takes practice. You need to feel the engine speed and match the gear speeds using the gas pedal. It's like a dance between you and the car. Section 5. Understanding reverse gear. Let's talk about going backwards. Reversing with a sliding mesh gearbox adds another piece to our puzzle. The idler gear. The idler gear is like a middleman. It sits between the countershaft and output shaft to change the spinning direction. When you choose reverse, the gear selector fork moves a gear to connect with the idler gear. The idler gear connects with a gear on the countershaft. Because of where the idler gear is, the output shaft spins backward. The idler gear makes the wheels turn the other way, and you go backwards. Section 6. Gear ratios and their impact. Let's talk about gear ratios. Gear ratios are fundamental to how a vehicle's transmission works. They determine how power is transferred from the engine to the wheels, affecting everything from acceleration to fuel efficiency. They're what make a gearbox so smart. By changing the gear ratio, the gearbox can adapt to different driving conditions, whether you're climbing a steep hill or cruising on the highway. Each gear has a different gear ratio. This means that each gear will change the relationship between the engine speed and the wheel speed in a unique way. This ratio decides how the engine speed and wheel speed relate. For example, a higher gear ratio means the engine has to spin more times to turn the wheels once, which is useful for low-speed, high-torque situations. Think of it like this. First gear has a low gear ratio. This is ideal for starting from a standstill because it provides the most torque. The engine spins a lot for each turn of the wheels. This high engine speed relative to wheel speed gives you the power needed to get the car moving. This gives you lots of power to get the car moving. It's especially useful when you're starting on an incline or towing a heavy load. It's like having a strong friend push a heavy thing. The extra effort at the start makes it easier to get going. As you go to higher gears, the gear ratio changes. Higher gears have lower gear ratios, meaning the engine doesn't have to work as hard to maintain speed. The engine spins less for each wheel turn. This is more efficient for cruising at higher speeds because it reduces engine wear and improves fuel economy. This lets the car go faster but with less power. It's like shifting from a sprint to a marathon pace. Less immediate power but more sustainable over long distances. It's like your friend doesn't need to push as hard once the thing is moving. The momentum helps, and less effort is required to keep it going. Each gear ratio has a purpose, letting the engine work best in different situations. Whether you're accelerating from a stop, climbing a hill, or cruising on the highway, the right gear ratio makes all the difference. It's about balancing speed and power, and the sliding mesh gearbox lets you do that. By selecting the appropriate gear, you can ensure that your engine operates efficiently and effectively, providing the best performance for the task at hand. Section 7. Advantages of the sliding mesh design. Even though it's old school, the sliding mesh gearbox has good points. First, it's simple, especially compared to new gearboxes. This means fewer parts, making it cheaper to build. Second, it's super strong. It can handle lots of power and tough conditions, which is why it's still used in heavy machines, and it's fun to use. Yes, it takes skill, but that's part of what makes it cool. You're part of the action, feeling every gear change. To Section 8, disadvantages of the sliding mesh design. No gearbox is perfect. The biggest problem is double clutching. Remember matching gear speeds? That's double clutching. It's how you match the gears by hand, and it's hard for new drivers. It's also noisy. The gears can be loud, especially if you do it wrong, and the gears sliding cause wear and tear, meaning more repairs. Section 9. Conclusion, legacy of the sliding mesh gearbox. So that's the sliding mesh gearbox. It's old, but it was super important for cars. It led to better gearboxes like the ones we have today. But even though it's not in many new cars, it's still used in some machines and loved by people with old cars. It shows how clever early car engineers were. So next time you drive a car with a manual gearbox, think about the sliding mesh gearbox. It's a cool invention. Maybe you'll even miss the days of double clutching and the sound of changing gears.